Calculating centroids. For simple shapes, we can use the fact that the centroid lies along the point at which the axes of symmetry intersect. So in the case of a rectangle or a square, it would be half of the base along and half of the base up. If we are taking our centroid to be relative to this bottom corner. For an equilateral triangle has got three axes of symmetry, so where it meets in the middle would be where its centroid would be. You will rarely come across that. For a circle has an infinite number of lines of symmetry and they all meet in the middle, which means that its centroid would be in the centre. Centroid, remember, is just a fancy word for saying the centre of mass of a shape or the average position of all the particles that make up that shape. Now, for more complex ones, these are the two that are in our formula booklet. We've got semicircles. Now, a semicircle has got an axis of symmetry. So it will lie along the axis of symmetry. In this case, its coordinate here would be, x coordinate would be the radius. And then its centroid lies some distance along that, and to do that we need to use this formula, which is 4 times the radius divided by 3 pi. For right-angled triangles we need to use also a formula to find the centroid location. Its location is here, roughly closer to the right-angled side than the other ones, and its location measured from the bottom bit is going to be the height divided by 3, and measured along from the right angled side would be the base over 3. You are given these in the formula booklet, however you're expected to be able to deal with them and also deal with if your right angled triangle has it here and you're asked to give it relative to this point. Now obviously, because that is base over 3 from this edge, well, that distance there in the x direction is going to be 2/3 times the base, or 2 times the base over 3. That is basically what you get if you took your base and took 1/3 of the base away from it. Likewise, in this particular example, because our y coordinate would be measured from the bottom here, that's going to be height over 3. Now, if you have a centre of a location of symmetry, a shape that is symmetrical, like some kind of weird hammer shape, well, in this case we know, because it is symmetrical, its x coordinate must lie somewhere along the line. We tend to use x bar to denote the centroid coordinate for the x and y bar for the other one. Now we can look at some compound shapes and how we would calculate things there. So here is a compound shape. We're going to use the same shape as we had before, which is some kind of hammer shape that hopefully is coming out roughly square. Now these are meant to be right angles, as good as we can get. So let's put some dimensions on here. This is going to have a base of 100 a height in this direction of 20. We're going to have a width here of 40, which means this will be 30 and 30 respectively. The height of this last side we are going to make 60. Now, to do this, we will need to first we need to split our shape and find the centroids of the two shapes we split it into. So let's split our shape here. It's simplest, you could split it into 3, however it's simplest to split it into 2. We can label these A and B, or 1 and 2, doesn't really matter. Now, the centroid of this first one, because it is a rectangle, is going to be in the centre. So for A, the centroid x bar by y bar will be equal, or rather, let's write that x1, y1. That's going to be, well, from the measure from the bottom corner, which is where we're going to put our origin, that is 50 along, and it is 10 up. For our shape B, well, we need to first remember that B, its centre will be here, which is 20 along and 30 up. However, it is already offset by 30. So the x coordinate of B and the y coordinates are going to be 30 plus the 20 to account for this offset in the x direction, plus 30 plus the 20 to account for this offset in the y direction. So that comes out as 50 and 50. Now the second thing we need to do is we need to write the centroid equations. These are the ones that help us calculate our centroid for the combined shape. These are not given to us, so we must learn these. They are x bar equal to sigma ai xi over total area. You may also see this written as sigma ai xi over sigma ai. That just gives us our total area, and y bar is the same, pretty much symmetrical, apart from we have a y instead of an x. I tend to use total area because it's easy to remember what we need. Then, our third step, we're going to draw ourselves a table to help us organise all the information in the calculations we need to do. So our table needs to have a column for shape, a column for the area, a column for the x's, for the y's, for the area times the x, and the area times the y. So our shape, we've got A and we've got B. We need to find the area of shape A. Quite often the dimensions will be given to you. Take care to check if they are millimetres or metres, etc. The area of shape A is 100 by 20, which is 2000. The centroid of x we just found. So for shape A it is 50, and the y is 10. Then what we must do is this column is the area of area of A, times the x of A. So we can look at the area in this column, in this row, and the x in this row. We've got 2000 times 50, should be 100, 1,000. 10,000 surely. Need to double check that one in the calculator. $100,000. Okay, and then this one is 2,000 times the 10. See here we're doing this column times this column to give this. And that's going to be 20,000. Very wonky table there. Now last thing, the next step we need to do the same for B. Now the area of B is 40 by 60. Which is 2,400. I need to review that. Obviously this is not drawn to scale. That's why this area, this second one, is so much larger. Now the centroids we calculate as 50 and 50. The area we calculate, well, we need the area times the x. So this is this area times this x. That's 2,400 times 50 plus, and then 2,400 times 50. Our fourth step is we need the totals for the area of our shape. So total areas of shapes, the AIs times the XIs and the AIs times the YIs. That is the total of this column here, the total of this column here, and the total of this column here. So this one is going to be 4,400. This one we need to work out 2,400 times 50 gives us 120,000. We need the total there, that is 220,000. Total of this one is 140,000. Then we look back at our centroid equations. We've got now the total area. We've got the total AI times the XI, which is this box here. We've got the total AI times the YI, which is this box here. Our x coordinate is given by AI times XI over A total. That is the 220,000 divided by 4,400. And unsurprisingly, it gives us the answer 50. This is unsurprising because our object is symmetrical and the centre line is at x equals 50. Our y coordinate, well, our y coordinate is this, the sum of the AIs times the YIs, so that's 140,000 divided by 4,400, which we work out to be 31.8181, which we are going to round sensibly. So our last thing we would do is we would state our centroid coordinates as a coordinate. That is going to be as 50 and 31.8 is our final answer. Now you should look through and feel free to rewind this video and use it to work through the examples that you have been given.